Evaluate the integral from 0 to 1 of e to the x minus x to the e dx. Now, there are no continuity issues here because e to the x is the exponential function. It is continuous everywhere. X to the e is a power function, and even though that is an irrational exponent, it is still continuous everywhere. There are no issues. So we can use the fundamental theorem of calculus. The antiderivative of e to the x is e to the x, and then minus, we can use the power rule here. The antiderivative of x to the e is x to the e plus 1 over e plus 1. And we need to evaluate this at 0 and 1. So when we plug in 1, that's going to be e to the first minus 1 to the e plus 1, all over e plus 1. And then minus, we plug in 0, e to the 0, minus 0 to the e plus 1 over e plus 1. And what do we get? E to the first is e, and then minus 1 to any power is 1. So that's going to be 1 over e plus 1. And then minus e to the 0 is 1. And then minus 0 to any power is 0. So that whole thing is going to be 0. And so 1 minus 0 is 1. And so we're just subtracting 1 at the end. So it's going to be e minus 1 over e plus 1 minus 1. Looks a little bit nicer if we move that fraction to the end. So we could write e minus 1 and then minus 1 over e plus 1. And if you wanted to, you could get a common denominator and put those all into one fraction. I am going to let you do that on your own. I'm not going to show my work here, but you should get e squared minus 2 over e plus 1. Take a moment and see if you can get a common denominator and throw those all together and get that, just for a little bit of arithmetic practice with some e's in there.